All right, everybody. Yesterday we practiced solving exponential equations. Today we're going to kick it up and do logarithmic equations. Remember, exponential and logs are just inverses of each other. That is the relationship. So yesterday we had to rewrite some exponentials in a log form. So you could probably take a guess at what we might have to be doing today. All right, just a couple of warm-up problems. Rewrite the following exponential expressions as logarithms. So just practicing. We're in exponential form. We're going to convert to log. Our base, of course, is 6. Argument is 36, and we always equal the exponent. That's all we have to do. Just rewrite them today. Same thing on this. Log. Our base is 5. Of arguments, 1 over 125. And, of course, we equal the exponent. So just reviewing how to convert, nothing too wild or crazy there. Okay, second set of warm-up problems, use the properties to condense. Now remember, condensing means we want to write it as a single logarithm. 2 logs added, condensed to 1 log multiplied. So 5 times 2x, and of course I'm going to make 5 times 2x 10x. Just a little simplifying, and you can go right to the final answer. I don't expect that intermediate step. Same thing, condensing, we want it to be log of something. We need the 7 to be moved. That, of course, really an exponent. Easy enough. And the last one, 2 logs subtracted, condensed down to 1 log divided. And of course, we're going to use our fraction bar to represent division. So our first argument over the second argument. So just a little quick review of some of the properties. All right, so here we go. We are going to solve logarithmic equations today. We did exponential in the previous lesson. Today, we are doing logarithm. So first, of course, simplify using the properties, like we just did in the warm-up problem. So if I can condense it down, I'm going to clearly use the properties. If there is a log, only a log, a single log on one side, we are going to rewrite it into exponential form. Because the inverse of a log is exponential. Now, if you have logs on both sides, this is one of our properties, I love it, they just simply cancel each other out. And of course they have to be in the same base, log base 5, log base 5. They always will be in the same base. You won't have anything too weird or crazy to deal with, but always take a look at that and make sure they are. So solve for x without the aid of a calculator. So first thing I'm going to do, of course, I see we have 2 logs subtracted, so I'm going to condense it down to 1 log divided. Now we have a single log, natural log, ln, a single log, so I'm going to convert it into exponential. Remember, our exponent, our base here on the ln is really e, so I'm going to convert it e to the 0 equals x over 2. Well, anything to the 0 power is 1, so that comes out pretty nice. Most of you can probably just do some mental math here. What number over 2 equals 1? 2. Or, of course, go through and do your algebra inverse operations and cancel your denominator out. Got it. So condense and then rewrite in exponential. Same thing for this one. I can't condense anything. It's really in a base e, so I'm going to put it into exponential. E raised to the opposite side is our argument. Now I can't use my calculator, so I can't punch in e to the 14th, so I'm just going to leave it. We've got x alone. That's as simple as it's going to be. All right, C, we have only a single log. Again, I'm going to convert it into exponential, starting with the base, raised to the opposite side, equals the argument. Then I'm going to solve that. Of course, I'm going to get rid of the squaring, or most of you can just solve it in your head. We're going to get 9. Technically plus or minus 9, but the base on a logarithm can never be a negative value, so we're just going to keep positive 9 for this one. All right, and then same idea for D. I'm going to take my base, raised to the opposite side, equals our argument. Now, of course, we can't use our calculator, so I couldn't simplify that. I'm just going to leave it as it is. I like that. Okay, let's do the letter E. So again, a single log. My base is E, so I'm going to raise it to the 8th power, equals 3x plus 5. Now, I can't use my calculator, so I'm not going to type e to the 8th in, but I am going to go through and at least isolate x. I'm going to subtract 5. Now, I cannot combine e to the 8th and 5, minus 5. They're not like terms. I'm just writing it down. And then to get x alone, we'd have to divide everything by 3. Looks crazy since I can't use my calculator, but we've got x alone. We achieved our mission. Got it. So you might have some kind of weird looking expression since you can't use your calculator on these. All right, next up, just a little bit of simplifying. We've seen these properties before, just making sure we remember them. ln and e, of course, cancel each other out to the exponent. Gotta love those. Same thing on b. E and ln, whether it's exponential first or the log first, doesn't matter. They cancel each other out. All right, let's look at c. Maybe just a little more tricky, but same thing. ln and e are going to cancel out, but just be careful here because you're subtracting off that entire exponent, x squared and 2, so you really have to think about distributing the negative through. And then I'm going to combine, of course, 3 minus 2 and make that a 1. Got it. So just reinforcing e and ln cancel each other out. All right, now we're actually going to solve these like I did in the first example. The only difference is I'm going to get my calculator out and actually punch in e to the whatever power. I'm going to get the crazy decimals. So same rules apply. Make sure you have just a single log, so you might have to use some properties to condense or something. And then, of course, we're going to rewrite an exponential. So single log, my base is really e to the negative 4 equals my argument. Now, just to show you, we've seen it before, but just to remind you, I'm going to pull up my calculator just to show you how to type a couple of them in. E, you're going to have to hit second, ln. And I'm just going to hit my exponent at negative 4. And there we go. We're going to round to 3 decimal places, so I'm going to write that as 0.018. I'll punch this next one in too, just to show you on this guy. All right, same thing. Single log, my base is e, so e to the 1.5 power, which we'll type in the calculator. And then you have the extra step to get x alone, we're going to divide by 2. All right, let's pull up the old calculator here. So second ln again, and then my exponent 1.5. I'm going to right arrow out of that, divided by 2. So I'm going to round that to 2.241. I kind of like these, they're not too shabby. All right, I'm not going to punch every single one in because you know how slow I type on that calculator, but I'm sure you can handle it. Now, you cannot add the 3 and 2 together. They're not like terms. 2 has an ln on it, 3 does not. So we're going to isolate the ln. First, I'm just going to subtract 3 from both sides. 10 minus 3, 7. And then I'm going to divide each side by 2. Now, you can leave it 7 halves. You could make it 3.5, 3.5, whatever you want to do. I'm just going to roll with it. I've got the ln by itself. So now, same thing. My base is e raised to the opposite side equals your argument. So I just converted it to exponential. I put e to the 3.5 into my calculator, and you end up with 33.115. Got it. So a little extra work on this one to isolate ln. Not the end of the world, though. All right, let's take a look at d. We do not have the log by itself. We've got the 4 in the front, so I'm going to divide it off. Now, 11 over 4 doesn't divide out to a whole number. I'm just going to leave it. So I've got my log, my single log, 1 log. Now I'm going to convert it into exponential. I'm going to start with the base, raise to the opposite side. We can punch that whole thing into our calculator. And then, of course, to get x alone, we're going to have to add 6. Now, be careful. You cannot just add this and make it 16 to the 11/4. Order of operations, you got to do the power first. So let's type this one in. So I'm going to do 10 raised to the 11 divided by 4. I'm going to hit enter, get that answer quick. And then I'm just going to add, you probably mentally do it, add 6 to it. So 568.341. So just be careful about your order of operations. Let's take a look at e. We, of course, already have the log by itself, so that's kind of nice. I'm just going to convert it into exponential. So 12 to the 6 equals x squared. So, of course, 12 to the 6, I just typed that in my calculator. It's a very large number. I'm not surprised. 12 into the 6th power. And to get x by itself, now I'm going to hit the square root. So that comes up to 1728. Now I am going to use plus or minus this time on it. I can use the negative because if I put negative 1728 in there and square it, it will turn out to be a positive argument. So it will work out for us. We will not have a log of a negative number. I did double check that. All right, let's take a look at f. So we have a single ln. You're in a base e. We're going to convert to exponential, e to the 5th. We can punch that in the calculator. Now, trying to get x by itself, I'm going to isolate or get rid of the square root by squaring. So the right side, of course, comes out nice, x minus 8. Now, power to power, 5 times 2, I'm going to make that e to the 10th, and then we would add 8 to each side. Remember, it's just a matter of typing it into your calculator, which I did earlier. Large answer, 22,034.466. Good. All right, final 2. So 2 logs added. So we want a single log, remember. So I'm going to use my properties. 2 logs added condensed to 1 log multiplied. So I'm going to make that x times x minus 8. You could go ahead and distribute that out too, which I am going to do here in just a second. I've got my single log. I'm going to now convert to exponential. Base to the opposite side, which some of you might just go ahead and put that as 9. And then I'm going to distribute my x through. Ooh, quadratic. Now, quadratic. I'm going to set it equal to 0. We know 3 methods to solve quadratics. Factoring, completing this quadratic formula. We're going to pray at factors. 3 squared, of course, is 9. Let's subtract 9 off. I think we're in luck. I think it's going to factor. I need 2 numbers that multiply to negative 9 and add to negative 8. Well, how about negative 9 and 1? So my 2, keyword here, potential answers, 9 and negative 1. Now the reason I say potential, of course I like 9, I have no problems with 9. I'm a little concerned about negative 1, because if I replace x with a negative 1, I'm going to have a log of a negative number, a negative argument, which of course we can't calculate. It's really an exponent, and we won't get a nice, pretty answer. So I'm just going to keep the 9 this time. So make sure you're checking your answers and you do not end up with the log of a negative number. We've talked about it. We can't calculate it. It just doesn't work. All right, final problem. 2 logs subtracted. Let's condense that down to 1 ln divided. So I had to use my properties. This is kind of nice because you have an ln on either side. So this is the first we've seen a log on both sides. Remember our properties, they just cancel each other out. Now we have to figure out algebraically how to solve this crazy looking equation. Well, as always, I would clear the fraction. Nobody loves their fraction. Well, I might, you guys know. I'm going to get rid of that x minus 2 and multiply each side by x minus 2. So of course the 9 on the left side is nice. The x minus 2's are going to cancel. I am going to go ahead and distribute x through on the right. Once again, we have a quadratic, so I'm going to set it to 0. I'm going to zero out the stuff on the left. And we're going to pray at factors. Okay, so I'm going to have minus 2x minus x. Let's combine it minus 3x. And let's check our factoring. Are there 2 numbers that multiply to negative 4 and add to negative 3? You got it. Negative 4 and 1. So keyword here, my potential answers are 4 and negative 1. Now I'm going to check. I want to make sure if I plug either 4 or negative 1 in my original equation for any of these x's, we don't end up with the natural log of a negative number. Clearly negative 1's a problem. We're just going to keep 4. If we put negative 1 in, not going to happen. And work on the first log. Negative 1 plus 4, of course, would give you 3. Negative 1 minus 2, negative 1 there. Those are going to be problematic. So I can't use negative 1. So just be on the lookout for that today when you're working on your homework. Be checking your answers so you don't have a natural log or a log and it's a negative value. Have a great day.